Hi, so this is the simulation VI that has been made for to test EOR's potential compact DAC uh, temperature and pressure regulation system. We're mainly focusing on simulating pressure here. Down here, the first thing we'll cover down here is the heating effect. So we have the percentage of the control variable that is affected by heating. Right now we've got it set to 2%. So that means 2% of the control variable's value is varying because of the temperature and pressure relationship and heat variation frequency. So right now we've got it at 0.2. That means that we're going to have one full cycle over 10 seconds. So that you can think about that as the um, well, the temperature regulation system coming on once every 10 seconds. Okay, so up here we have graphs, plunger position, set point, measurement pressure, set point and measurement pressure, and just measured pressure. These ones are going to be the ones chiefly showing us what's going on and how well the PID parameters are actually adhering to our set point. Down here we have the duty cycle, and that is going to be the PMW signal that is varying the 0 to 10 volts to the plunger of the pump. Measurement noise as well, so I wanted to simulate the noise that we experience when we communicate with sensors. So we have 1% measurement noise. The measurement noise that we have our sensors is very low, it's about 1%. And we want to be able to test that our PID control system is able to handle measurement noise as part of its operation. We have set point here, so pressure in this case is just going to be measured in percentage of full scale. So we have 100% full scale, or right now we're set at 60 or 0. Manual controls down here. We're not going to be using these apart from stop, just to stop the program. But down here, in theory, we can control the control value if we were to deselect that and then cycle through this. PID parameters, so these top ones are the PID parameters of the control regulation system. These are the main ones we're going to be focusing on. These PID parameters are for the plant on the box diagram, and that basically determines the pressure response of the thing that we're measuring. So that simulates that allows us to produce a measured value of what we're trying to control in a realistic way. Now, we're going to be simulating this as if the pressure is starting from 0 and then coming up to our set point value. It's important to note that in a realistic system, this is going to look very different, but the purposes of this simulation is just purely to show that PID control systems are very much possible with LabView. We want to show that even when relationships are variable, with the thing you're measuring, you're trying to control even is a very variable thing that can be affected by noise. It can be affected by other phenomena such as temperature. Well, you might call it the same phenomena, but they occur because of different things. That this system can still operate effectively. So I'll quickly run through the block diagram. Set points up here, that's just our set point value. This is our main control system here. This is PID. So basically, like without all this stuff, which is relevant to simulation and display, our main control system is down here, and we'd have a lot more of these operators in a real system that are basically just to interface with the hardware. We don't need these obviously because we're not interfacing with any hardware, but they'd be like voltage in, voltage out, serial communication in, serial communication out, making files, that sort of thing. But it's not particularly important for this application because again, we just want to prove that this can be done. Timescale down here, not super important, but down up here we have duty cycle graph. That's producing our PMW signal. This is our plant. Again, this is what's simulating a realistic measurement response. Over here we have the heat variation system, and that is directly affecting what is down here, our measurement noise, and our feedback control variable. Just come back into the PID. So this out here is our measured pressure as affected by our control and the plant parameters. And then these just put everything in nice graphs. Okay, we'll enter some values in here and get the simulation running. So these are all set to the standard values, but we'll do some adjustments. So we can see in the first instance, green here is our plunger position set point. It's having to vary to get the pressure up to our set point, and we're quite nicely hovering around there due to our PID parameters down here. We see the duty cycle being sent to the pumps to do this. We get just a bit of a closer look at the set point and the measured pressure here. So we'll have a go at changing some values. I'm not going to do it in any particular order, or we'll try and tune it effectively. But we're just going to guess, okay? So our integral time, a larger integral time will have a slower effect on our measured pressure. So we'll go for 0.1. See if that will bring it up or down, or I think it might bring it closer. Oh, yes. So it's interesting. It seems to be sort of almost looks like it's hovering sinusoidally around the set point. So we ideally want to, as this is pressure, we ideally want to maximize accuracy, pressure accuracy, and this is not too bad. Almost about 1% of variation, not too bad. But we're going to reinitialize that back to what it was. Bring this up. This is actually currently sitting at 0.0001. We're going to bring it up. What's it? 0.005. See what that does to it. So our plunger set point control has become a lot more noisy. This kind of